Welcome students, good morning again into the 12th science chemistry class. Up to the last lecture of this chapter number 4, that is the thermodynamics and energetics, we learned the types of the processes. Now there are totally, that is 6 type of processes. Now the first two we already learned, that is the isothermal process, in which temperature of the system remains constant throughout the transformation, that is the reaction or process. In that delta T is equal to 0, that means T2 minus T1 is equal to delta T is equal to 0 in the isothermal process. Now secondly we learned, that is the isobaric process. The process in which pressure of the system remains constant. Generally all the reactions in the laboratory are carried out at the constant pressure, that is the atmospheric pressure 1 atmosphere. So that are the isobaric processes. Into that also P1 is equal to P2, therefore P2 minus P1, that is equal to delta P is equal to 0. Now this is the third process. The name of that process is Isophoric process. Now isophoric means volume of the system remains constant throughout the process or throughout the transformation or throughout the reaction. That means V1 is equal to V2, therefore V2 minus V1 delta V is equal to 0. Now if the reaction is carried out in a closed container, then the volume of that reaction remains constant, and that reaction is the isophoric reaction. So see students, what is the definition of this isophoric process? It is a process during which volume of the system remains constant during the transformation, that is reaction, is called as the isophoric reaction or process. A chemical reaction carried out in a closed container, for example, any chemical reaction which is carried out in a closed container is isophoric reaction. And for such reaction, for isophoric reaction or isophoric process, V1 is equal to V2, and therefore V2 minus V1, that is delta V, is equal to 0 in case of the isophoric process. Now next one, that is the adiabatic process. Now what is meant by adiabatic process? If the heat change is 0, that means there is no heat exchange in that process, such process are called as the adiabatic process. That means a process in which there is no exchange of heat between the system and surroundings. The process in which there is no exchange of heat between the system and surrounding are called as the adiabatic process. Just like that of the isolated processes. Isolated processes are adiabatic processes. That is process carried out in a thermos flask. That is the or the process which is carried out in an insulated container. That are the adiabatic processes. So process in which there is no exchange of heat between system and surrounding is an adiabatic process. In adiabatic process, Q is equal to 0. That means no exchange of heat. Q means heat. That is equal to 0. And system is completely isolated from the surroundings. Remember student, the adiabatic process is completely isolated from the surroundings, and there is Q is equal to 0. Now if the adiabatic process is carried out in a closed container which is isolated or which is insulated, then what happens? If there is reaction between the reactants is there in the, that is for example in the thermos flask, if there is any chemical reaction is happen, and in that reaction suppose that reaction is exothermic reaction, but as the system is isolated or reaction is isolated, though the reaction release the heat, exothermic reaction, though it releases the heat, but the heat remains into that container. And due to that, what happened? Due to that, the internal energy, as the temperature increases due to the exothermic reaction which is carried out into that of the thermostat. That means there is work done and heat is released, and due to that the internal energy of the system increases. But if the reaction is carried out and the reaction is endothermic by absorption of heat, but the heat is not absorbed from the surrounding, but in that reaction the heat get absorbed, and due to that temperature falls, but the internal energy of the system increases. Remember that. So what is that? For an exothermic process, which is adiabatic exothermic process, completely isolated, heat is released which rises the temperature and of the system, rises the temperature of the system. And the process which is endothermic, the temperature falls into that. And this results in either increase or decrease of internal energy in this way. That is the adiabatic process. Now see the next process, that is the reversible process. As the name suggests, reversible means after some time, if the reactants are changes into the products, a equilibrium state is there at which the concentration of reactant and concentration of product remains constant. That means though the process is carried out at equilibrium state, then how many molecules of the reactants transfer into the products, exactly same molecules of the products are transferred again into the reactant. That are the reversible process. That means in reversible process, the driving force at equilibrium, what happened? The driving force and the opposing force becomes equal, or there is only infinitesimal change, very slight change into the driving force and the opposing force. But if the driving force is infinitesimally greater than the opposing force, very slightly greater. But if we increase the opposing force than the driving force, what happened? The reaction reverse. The reaction carried out from product to reactant. Such reaction is called as the reversible reaction. So, any reactions, if there is that reaction is carried out in a closed container, or the gas is present in a closed container, and into that there is the piston is applied, the opposing force, now the driving force, which is the atmospheric force, external force, pressure, and the opposing force means the pressure of the gas enclosed in the cylinder. If they are same, then the reaction is at equilibrium. But if there is slight increase in the driving force, due to that the gas get compressed, the piston goes inwards, the gas get compressed and volume of the gas decreases. But if the pressure P of the gas is increased slightly, then the piston goes upward and the volume increases. Now in this way, the gas enclosed in a cylinder with weightless and frictionless piston is the example of the reversible process. Now see students here, what is the actual definition of this reversible process? Very important definition, always asked into the examination. So reversible process, a process conducted in such a way that at every stage the driving force due to the pressure P is infinitesimally greater. The driving force due to the pressure P of the gas is infinitesimally greater than the opposing force due to external pressure Px. The opposing force have opposing force Px, P external, then such process can be reversed by a slight change, that is infinitesimal change of the opposing force is called as the reversible process. That means the opposing force, if applied, the reaction get reversed, and that process is called as the reversible process. And the best example is a gas enclosed in a cylinder fitted with weightless and frictionless piston having external pressure Pex and the pressure of the gas P. Now let us learn that example and what are the features of the reversible process. We have to learn that now. But take the screenshot and write down the notes in your notebook. Now let us learn the example and characteristic features of the reversible process. Now pay attention students on the blackboard. Now this is the example of the reversible process. Now consider a gas enclosed in a cylinder fitted with a movable piston. Let the external pressure Pex on the surface of that piston is equal to the pressure P of the gas. That means neither expansion nor compression can take place because both the forces, driving forces and opposing forces are equal. That is P external is equal to pressure of the gas P. Now that means the pressure P of the gas and the external pressure Px, which is on the piston of that gas, are equal, and therefore neither expansion nor compression of the gas occurs. Then the system is said to be in mechanical equilibrium. When both of the forces, driving force and opposing forces, are equal, the system is said to be in a mechanical equilibrium with that of the surroundings. Now consider the P external is reduced, that is the pressure present on the piston of the gas get reduced by an infinitesimal amount, very slight amount. Then what happened? The piston moves upward, moves out slowly because the P external becomes infinitesimally less than the P, and due to that the piston moves outwards slowly, allowing the gas to expand. Due to that, what happened? The gas get expand, volume of the gas increases, and if P external is slightly increased, if the pressure on that piston is slightly increased, then the P, that is the pressure of the gas present in the cylinder, then the piston moves inward with a compression of the gas. Now, so any infinitesimal change causes this reversible process to occur in a reverse direction. Any slight change can causes the process to reverse, and this process, the process to occur in the reverse direction, that the process is said to be thermodynamically reversible. Both the forces are equal, but if any slight change in any force can reverse that reaction, is thermodynamically reversible reaction. Now, which are the characteristic features of this reversible process? Now, the features of the reversible process. The first feature is that the driving and opposing forces differ by an infinitesimal amount. That means the driving force and the opposing force both are only differ by a slight amount, by infinitesimally, that is the amount, that is very slight. They are nearly equal. There is very slight change between the, that is the driving force and the opposing force. This is the one characteristic feature of that reversible reaction. First characteristic feature. Now second is the process can be reversed by an infinitesimal change, very small change. The process can be reversed by a very small change. The process can be reversed by infinitesimal change in condition. Now that is the second feature. The process can be reversed by infinitesimal change in the condition. And first is the both of the forces are nearly equal, or both of the forces are differ by infinitesimal amount. That is the driving and opposite force. Now third one is the reversible process proceeds infinitesimally. Very infinitesimally they infinitesimally slowly, The process proceed infinitesimal slowly, that means very slowly. Reversible process proceeds or occurs very slowly, that is reversible process proceed infinitesimally slowly, and takes place in infinite number of steps. As the process is very slow, infinitely slowly, so it takes place in a infinite steps, many steps. That is the third characteristic feature. The process is very slow and it is carried out by the infinite number of steps, or proceed by infinite number of steps. Now, fourth one is at the end of every step, the process at the end of every step of that process, the system attains mechanical equilibrium with the surroundings. Remember, student, at every step, this reversible process attains a mechanical equilibrium. There is always equilibrium at the end of every step of this reversible process. That is, the reversible process carried out in an infinite number of steps, and at the end of every step, the process attains the mechanical equilibrium. That means all pressure, temperature, again all that of the properties are always in a mechanical equilibrium. Now that is about the types of the processes, that is the reversible process, student. If you understand this video, you like, share this video so that the maximum students can be benefited by all these types of processes and their characteristic features. So thank you for watching this process. You first take a screenshot and write down the notes in your notebook in a beautiful handwriting. Thank you.